Exercise 12.2, question 6a, just looking at this question here. Solve sine of 2x plus pi and 6 equals root 3 cos 2x plus pi and 6. Now, does that remind you of anything?
The thing that sine plus cos equals 10 or something.
No. Yeah, sine on cos is 10.
Yeah,
So it might remind you of something like this if you were solving sine x equals cos x. Do you ever remember doing that last year? So you divide, so when you've got sine equals cos, all you do is divide both sides by cos, and what do you get? If I divide both sides by cos, I get sine x on cos x equals cos x on cos x, which is tan x equals 1. So that's the idea we're using. Now, the only time you can ever use that is if whatever the sine is, you know how sine of the bracket and cos, the same thing is in the bracket. So that's good. Because what's in the bracket here for sine is the same as what's in the bracket for cos, you can apply this idea. So if you're ever asked to solve anything like this, sine x equals cos x, all you do is divide both sides by cos because tan is sine x on cos x. So you're actually not losing either one. The definition of tan is sine on cos. So tan is just the combined ratio. So what we want to do is divide both sides by cos of that. So, or I can just put it down there. Is that, so I've got sine of 2x plus pi on 6 over cos of that. So if I'm dividing both sides by that cos of that, don't I lose the cos? What do I end up with on this side? Just root 3. Are you okay with that? So what I'm really doing is dividing through by cos of, I'm just dividing both sides by the cos thing. So I'm just putting that cos down there. And if I divide this by cos, the coses cancel, you know. So what I'm doing is what I've done over here. Now, sine on cos, the question just becomes tan of 2x plus pi on 6 equals root 3. And we're solving that for 0 less than or equal to x less than or equal to 2 pi. So this is what we're really solving. So when you're asked to solve that, you're really just asked to solve this with the tan. Okay, so what are you looking for here? That what's in the brackets are identical. If what's in the brackets are identical, you can just use what you would have done in prelim when you were asked to solve sine x equals cos x. Same thing. Sine of blob equals cos of blob. All right, as long as they're the same, just divide by cos. All right, now how do I do this? First thing, I'm solving tan 2x plus pi and 6. So my domain at the moment is from 0 to 2 pi. So I need to build up 2x pi and 6. So I multiply first by 2x, by 2, sorry. So first I need to make my domain in terms of 2x plus pi and 6. First, multiply each of these by 2, and what do you get? That's the question. Solve this for that. 0 times by 2, what do I get? 4 pi. And then you've got to add pi and 6 to each of these. And what do you get? Do you get what I'm doing? So this, they're asking you to solve this for this domain from 0 to 2 pi, but you have to adjust the domain. So I get 4 pi plus pi and 6, which is 4 and 1/6. What's the fraction 4 and 1/6? So you're going 4 pi plus pi on 6. So we're going like this, 4 pi plus pi on 6. If you just ignore the pi's, you're just really doing 4 plus 1/6 as fractions. 4 and 1/6, that's 25 on 6 pi. And this one is pi on 6. So you're adding pi on 6 because we're trying to build up 2x plus pi on 6. So all you do on your calculator, if you have to, 4 plus 1/6. Ignore the pi's. It's like 4x plus 1/6 x. Okay, so that's your new domain. Okay, so, right. Now, what's my first step? Tan of that is root 3. So my first step 1 is my acute angle. Acute angle that. So what you want to do, just pretend that bracket is a one thing. How would you do it if that was just tan of x? You would say acute angle that is, you say tan of what is root 3? Tan of what? Tan of 60. So tan of this is root 3. So tan of 60, that's pi on 3. So that's your step 1, your acute angle. Step 2 is your quadrants. Are we positive or negative? We're looking at positive because tan of that is positive root 3. So we say tan is positive in quadrants 1 and 3. So then we draw a little sketch. So my angle is my acute angle is pi on 3, which is 60. And that acute angle is sitting in quadrants 1 and 3. Now I read off my answers. But I have to make sure I go around the right number of times. So I'm going to put my answers down here. So 2x plus pi on 6, because that's what we're trying to solve, tan of that. So I'm getting all my answers for this. Because normally you would just have an x sitting there. All right, so what do we think we do? First answer. So pi on 3. Do you know what this pi on 6 is? So my answers have to be between 30 and 4. How many times around? What's 4 pi? That's twice around plus a bit more. It's twice around because 4 pi, look, 0, pi, 2 pi. 0, pi, 2 pi, 3 pi, 4 pi. Every 2 pi is once around. So it's basically twice around plus 1/6 plus another 30 degrees. Because I added pi on 6, which is 30 degrees. So my first answer is 60 degrees. That is bigger than 30, so it fits in. I'm allowed to go from 30 to, I don't know, twice around 750. Twice around 360, 360, that's 720 and a bit more. What's the first answer? Good. Next one, pi plus pi on 3. That's 1 1/3. It's pi plus, let me write it as pi plus pi on 3. So 1 pi is 3 on 3. That's 1 1/3. See how it's pi? So it's 1 1/3. Can you see it? Right, what's the next one? So now I'm up to 2 pi. What's my next one? I'm going to write it out fully. 2 pi plus the first one and 2 pi plus this one. So I've got my first two. Add 2 pi to this and that. What would I get if I add 2 pi to this? 3 pi plus pi on 3. So I've got this one. I'm adding 2 pi to that one and I'm adding 2 pi to this. 2 pi plus pi on 3. Now I'll stick the next one in, but it's not going to fit. So now I'm up to 4 pi. Look, once around, twice around. If I did want to add this last one, it would be 4 pi plus pi on 3. But it's actually going to be out. I'll show you how. Look, 2 pi, 4 pi plus pi on 3. I'll just put it in for now. Just simplifying those, I've got that. Isn't that 4 pi on 3, 1 1/3? This is 2 1/3. What's 2 1/3? And this is 3 1/3, 10 pi on 3. And that's 4 1/3. Ooh, what's 4 1/3? Yeah, 13 pi on 3. Now, that one is out, but you can't see it yet. So now what do? I've got those. That's what 2x plus pi on 6 is. Now what do? Subtract pi on 6 from each, because I'm solving now. So it's a third minus a sixth. What a pain. I think that's a sixth. Then 4 over 3 minus a sixth. That's 8 on 6 minus 1 on 6. Thank you. That minus a 6, that's 14 on 6, 13 pi on 6. This is 20 on 6 minus 1 on 6, 19 pi on 6. And the last one, see how I'm doubling them both to get them on 6? 26 on 6 minus 1 on 6 is 25 on 6. Oh, it fit. It fits. No, it doesn't. It doesn't fit. It doesn't fit because, yeah, look, I'm now on this line. Do you see that it doesn't fit when you've got 2x? It's bigger than 4 pi. See, when I wrote this line out, they've all got to fit in down there. When I write out 2x, they've all got to fit in here, in the 2x line. Do you see what I'm doing? And when I write x, they've all got to fit into the top line. Now, do you sort of get it now? So now x, divide them all by 2. The 2 goes on the bottom. What do you get? And they're all on 12. Now, they all look good. Now, pi on 12, it's 1/12. That is, I think it's too small. Wait. Keep going. 13 pi on 12. What's this? 19 pi on 12. 25 pi on 12. Now, that is bigger than 2, do you think? 24 on 12 is 2. That's too big. It's out. 2 pi on 6. Pi on 12. What's pi on 12? 15 degrees. That's okay. That's allowed. We're in. So your final answers, look, your final answers have to be between 0 and 2 pi. Can you see? Your final answers. Look, if you don't, it is hard to check on this first row. It is hard. So if you want, don't worry about checking here. Do the next row, do the next row, and just make sure they fit in at the very end, that all of these fit into the original question from 0 to 2 pi. Do you understand why? Because now I'm in terms of x, it has to fit into the x one. So if you want, leave it to the end and cross off what's not right. All right? Question.